Hi, today we will be looking at the changes in properties we can observe in the periodic table. In front of you is a half-length version of the Mendeleev table. You can see how the elements are arranged here. Recall, this is the distribution of them by periods. There are currently 7 periods in the Mendeleev table, as well as by group. Currently, this version of the table includes 18 groups. Inside the periodic table, there is a division of elements into S elements. These are the first 2 elements in any period. Then there is a block of P elements which goes up to the 4th period. And starting with the 4th period, there is a D block. It starts with scandium. And then lower down in the 6th and 7th period are the lanthanoid and actinoid elements, the F elements. Today we will find out with you how the properties that are in the periodic table for chemical elements change. So we're going to first look at the changes in properties by period if we move from left to right on the periodic table in each period. So the metallic properties, well, first of all, let's remind ourselves that metals are elements that tend, in order to complete their outer level, to give up electrons. The easier they make it, the stronger the metallic properties look. The more weakly they do this, the correspondingly weaker the metallic properties will be expressed. So how do metallic properties change? First on the periodic table in each period are the alkali metals. These are very active metals because they have only 1 electron at the outer level. Of course, they give up that electron easily. Then come the elements that have 2 electrons on the outer level. They will also give it away easily, but not as easily as the alkali metals do. If we're talking about small periods, which are the 1st, 2nd and 3rd periods, the rest of the elements arranged by element will give up electrons even more weakly. So the metallic properties by period from left to right will naturally decrease. But here I would like to warn you that for the elements that we call transitional elements or D elements, such a pattern generally looks like a basic general pattern, but in it, since the structure of these elements is more complex, there may be exceptions. I'll give you an example. For example, copper, which stands in the 11th group of the 4th period, stands before zinc. It would seem that copper should be stronger than zinc, but it is not. If we look at the range of metal activity, we will find that copper is after hydrogen and zinc is before hydrogen. The same pattern exists in some other periods, but in general the metallic properties will certainly decrease over the period. Now, if we are talking about non-metallic properties, what do non-metals do? Non-metals tend to accept electrons, so for the first elements, the ability to accept electrons is practically absent. They will not accept, metals do not accept electrons. But as soon as we move into the block of non-metals, it becomes possible for these elements. Moreover, electrons will be accepted starting from the 14th group, because it is absolutely unprofitable for elements before this group. And the further the elements are located in the period and closer to the end of the period, the more such properties will be strengthened. Then the non-metallic properties in each period increase. But please be careful. The elements that are in the 18th group are called noble gases, and such elements have a completed external level and therefore will neither give nor take electrons. And even if they react, for example, with the second, they will only give up electrons because they will accept them, of course, the second and other halogens, now the atomic radius. The atomic radius decreases in a regular way by period. At first glance, this seems strange. Why does it decrease? Because there are more electrons at the outer level. The point is that the more electrons there are at the outer level, the more they are attracted to the nucleus. So the radius decreases in period. The largest radius in any period will be at the very first standing element, and therefore at alkali metals. And the smallest radius will generally be that of the inert gases. Now the properties are acidic. Here I would like to remind you that acidic properties are a continuation of non-metallic properties. Therefore, the more to the right of the period an element is, the more acidic properties will be expressed. Then these properties will increase, just like the non-metallic properties. Meanwhile, what about the properties of bases? Since these properties are an extension of the metallic properties, they will change in exactly the same way. They will decrease. Therefore, the strongest bases form again the alkali metal family. The next sixth point I introduced here is the concept of electronegativity. Electronegativity is the ability of an element to attract electrons to itself. It's actually an extension of the properties of nonmetals. Therefore, such properties will in this case. But be careful, noble gases cannot attract electrons to themselves. So in each period, the most non-metallic, it's also the most electronegative element is in group 17. These are the elements halogens. The ionization energy, and in particular the first ionization energy, this is also an extension of the properties of the non-metals, the ability of the energy that is needed to tear off electrons. But non-metals don't have electrons that are easily ripped off. So the electron stripping energy will increase as the properties of non-metals increase. Well, the electron affinity energy is a logical extension of the non-metal properties too. And it's the ability of an element conversely to capture an electron. And the easier it is to do that, the more energy will be released. Well, now let's look at how things are in groups from top to bottom. And we'll go in the same sequence. Metal properties. What I'd like to say here is that the lower down the metals are, the more energy levels they have, which means the attraction to the nucleus becomes weaker. And therefore it's easier to give up electrons. Consequently, the metallic properties will increase. But please be careful. We should be especially concerned about the metals of the side subgroups because these elements have peculiarities of their structure. Non-metallic properties, on the contrary, will decrease as they are the opposite of metal properties. Atomic radius. Here there are no tricks, accordingly it will increase. And the largest radius is at those elements that are located to the left in the periods and below. In this case, the properties of acids as well as non-metallic properties will weaken. And at the same time, the bases will increase. Electronegativity, energization, and affinity energy at electrons change as non-metallic properties do, and they will naturally decrease. Thus, knowing the general patterns of change, we can say that there is a pattern in the periodic table. It is called periodicity, which we can observe for any period and for any group. And only for metal elements, which are D elements and then F elements, here we need to know the peculiarities of the structure of these elements in order to correctly predict their chemical properties. Hopefully, in this case, this has become clear to you, and you will be able to characterize any element in the Mendeleev table and compare it with its nearest environment. In my opinion, this is the great function of the periodic table. Goodbye, guys.